Thank you for being here. In this talk, I walk you through the history and evolution of DNS, from its origins to the way we've secured it and how it's sometimes used to filter or control content online. Okay, let's start with a brief historical background. DNS was developed in early 80s, as Francesco previously mentioned, to solve the scalability issues of the old hosts txt file. You already heard of this file. The key institutions involved were IANA under John Postel and the IETF, which still oversees DNS standards today. These groups laid the foundations of a globally distributed hierarchical naming system. So let's start with the cyberspace. Here you can see that cybersecurity scholar Martin Libicki describes cyberspace as having 3 layers. The physical layer includes things like fiber cables and satellites. The syntactic layer is where protocols like DNS operate. And the semantic layer is where meaning emerges, which relies on the correct functioning of the lower layers. DNS sits at the heart of the syntactic layer, but supports the semantic one directly. Internet governance. The governance of DNS involves a web of actors: governments, civil society, private companies, and technical communities. DNS policies are often technical, but their implication, as you can imagine, are political as well. According to the Tunis Agenda, Internet governance is the application of shared rules and procedures by different stakeholders. This includes everything from managing names and numbers to making decisions that affect how the internet evolves. And DNS governance fits squarely into this model. Here you can see the complex ecosystem of internet governance, from ICANN and IANA to IETF, RIRs, and various registrars. Each plays a different role in maintaining and delegating authority in the DNS hierarchy. John Postel, he was a foundational figure in internet history. He managed the root zone before ICANN existed and edited hundreds of RFCs. His work was based on trust and technical merit and not institutional power. Postel's famous principle was: be liberal in what you accept and conservative in what you send. This ethos of interoperability still shapes DNS and internet standards today. ICANN is now the main body managing the root zone and the policy development. It balances the technical stability of DNS with geopolitical pressures. IETF. In the IETF Internet Engineering Task Force, Decisions are not made by vote, but by rough consensus. That means the dominant technical viewpoint, after open discussion, prevails. It's a process that values good ideas over formal power. Here you can see how RFC 2418 shapes the rough consensus process. As you can see, I'm going very fast on these initial slides. Domain names, hierarchies, root servers, registries. DNS is hierarchical by design, from the root down to TLDs. And registries manage these zones, often delegating control to registrars and eventually to end users. Here you can see country code top-level domains like .it. They are managed nationally, while generic top-level domains like .com are global and commercial. The distinction has implications over governance and policy. Infrastructure domains, this kind of domain names are not widely known. Some TLDs are not meant for users, but for infrastructure like ARPA. These support reverse DNS, enum for telephone numbers, and internal network functions. Then you have generic restricted top-level domains where you must meet some requirements to register. Then we have sponsored top-level domain. We have also test top-level domain. These are restricted, sponsored, as you already seen. These hard test domains serve special roles, from professional identity to software testing as test TLDs, for example. Okay, names and numbers. We have a forward resolution from a domain name to a number, IP address, IPv4 or IPv6, of course. But we have also the other way around. So from a number resolves to a name, okay? Here we see the structure of a DNS name from subdomain to TLD to root. This is a tree model, and it enables scalable delegation and autonomy. The DNS root is served by a network of globally distributed servers using Anycast to ensure redundancy and resilience. As you can see from this slide, the root server system consists of almost 2,000 instances operated by the 12 independent root server operators. Root servers are 13 from A, the A letter, the first letter of the alphabet, to M. So 13 root servers operated by 12 operators. That means that one operator operates 2 root servers. So around the world, we have Anycast instances of the main root servers. This ensures the stability of the DNS system. Okay, here you can see the main TCP and UDP port 53. In IANA registry, you can see that Paul Mokapetris is the person who is responsible for this port. This is my friend Paul Mokapetris. He is an internet pioneer, and he edited the two main DNS RFCs, 1034 and 1035. Okay, here you can see a series of slides where I put what was the effort by IETF in shaping the DNS over time. 1987, 1993, 94, 95, 98, 99. I go fast here. 2004, 6, 8, 9, 10, 11. Look how many RFCs have been published by RFC editor. It means that DNS was shaped as the internet industry changed over time. We are 2020 here, 22, 23, 24, and now 25. We have so a lot of new features introduced in DNS over time. But let's focus on the protocol. The DNS protocol is built around three key elements. The domain namespace, which defines how names are structured, name servers, which store authoritative data, and resolvers, which retrieve data on behalf of clients. This structure was formalized in RFC 1034. Okay, what resolvers do? Resolvers are the components that query name servers and cache the results. They are the bridge between end users and the DNS system. Here you can see that the DNS is comprised of three core components. The namespace and the resource records are remember, and the authoritative servers and the resolvers. These three elements are still the foundation of DNS today. Here we can see the hierarchy. A resource record includes a name, a type like A, MX, or TXT, a class, usually IN, it stands for internet, and a time to live, and of course, data. The hierarchical nature of the DNS makes it scalable and allows delegation, of course. We have a lot of resource records they go beyond what the RFC 1034 forecasted. For example, we have the quad A for host IPv6 address. We have, for example, everything related to DNSSEC, DNS key, DS, etc. So we have a lot of resource record now. This slide following now reinforce the idea that DNS is a structured database with each label representing a node in a tree, and each node storing information in the form of resource records. So we have authoritative name servers. They store DNS records, and of course they answer queries from resolvers. They can serve zones directly or refer queries to other name servers. Yes, this is the how a zone looks like in the servers. Then we have resolver. They work recursively. They start from the root and follow delegations until they reach the authoritative server for the name in question. Caching, of course, improves performance and reduces load. Here you can see how reverse DNS works. Reverse DNS uses infrastructure domains to map IP addresses back to names. It's used for logging, spam filtering, and diagnostic purposes. Now, let's come to a fundamental principle in the DNS system: unique DNS root. RFC 2826 explains why a single globally unique DNS root is a technical necessity. Multiple routes would lead to inconsistencies and could break the global namespace. So there should be a unique naming authority to avoid clashing of domain names and resources. This is a technical requirement. During the last 20 years, we have seen a lot of alternative routes namespace, but they failed, of course. DNS between security and privacy. We now shift from the architecture of DNS to the issues of security and privacy, which have become central concerns in recent years. This is the main website voted to DNS privacy. This is the main resource for every project and every news about this topic. Privacy. RFC 7626 outlines how DNS queries expose metadata like the domain name, source IP, and even the user's behavior. This creates opportunities for tracking and surveillance. Strict privacy. In some cases, privacy is a functional requirement. The servers won't work without encryption and authentication. Then we have opportunistic privacy. Other protocols offer opportunistic encryption. This is not mandatory but preferred. This improves privacy when available without breaking functionality when it's not available. DOT, DNS over TLS. DOT uses TLS over TCP to encrypt DNS queries. It reuses sessions to improve performance and protect against eavesdropping. Reusing a single TCP TLS session reduces the cost of opening new encrypted connection for every query. DNS of DTLS is a UDP-based encrypt protocol. It's still experimental but useful for constrained environments. It will be replaced by DNS over QUIC. DNS over HTTPS transmits queries as HTTP requests over TLS. It uses GET or POST methods and runs on port 443, making it very hard to block nowadays. Let's see the time. My time, I have another hand of minutes. DNSSEC, this is a problem statement. Even with encrypted transport, how do we verify that the data is authentic? That's where DNSSEC comes in. It uses digital signatures to protect the integrity and authenticity of DNS data. Records are signed with private keys and validated using published public keys. Every zone has a key pair. The private key signs data and the public key is published in DNS itself for validation. Resolver validation. A resolver checks the digital signatures in the response using the public key. If validation fails, it signals a potential attack or misconfiguration. Okay, ISPs nowadays are at the crossroads of cybersecurity and censorship. In fact, DNS can be used both for security and control. ISPs are often asked to block domains for good reasons or bad. This places them at the crossroads. In Italy, blocking mechanisms are widely used. ISPs enforce DNS or IP-based restrictions under regulatory mandates, sometimes with limited transparency. Censorship, this is the definition of censorship from Wikipedia. It can be good, it can be bad, it depends. But we have two contexts of implementation. In fact, blocking can target content publication or access. Both approaches use DNS or routing as enforcement tools. Why censorship? We have collective interests like child protection or national security, but also individual rights like copyright enforcement. Two techniques: DNS manipulation with landing pages and routing level blackholing of IP addresses. And so I think we have reached the time, well, not questions, not in at this time, but I will leave now the floor to Francesco to go ahead with the filtering um, techniques of blocking applied to DNS. Francesco. Francesco?
Okay, okay,
Hey.
I am. Thanks so much, Antonio, for the great presentation. I listened in 2022 to a speech of Mocha Petris. It took place in Cesena in northern Italy at the local university campus. Great person, and I'm so proud you are a very close friend of Mocha Petris. By the way, can you see my slides? Are they visible?
Yes.
Okay, thanks a lot. So just to be very, very short and efficient, I am the founder and CEO of Flastat, and just after listening to the great story provided by Antonio Prado, talking around the origin of the DNS protocol, I just want to talk about the protective DNS. So we are mentioning the modern era of the DNS protocol and the protective DNS feature. So DNS is capable of providing the normal DNS resolution operation, but through a certain mechanism type of blacklist DNS security, DNS logic, we can talk around protective DNS. So forcing DNS to reply according to our security selection schemas. Several actors enter the field in the cyber protection defense. DNS protection, it's our stuff, firewall, intrusion prevention system, intrusion detection system, antivirus, and deep packet inspection. The more actor you implement, the higher level of security probably you would reach. DNS is not the panacea for everything, but I believe DNS can play an active, very important role in the security. DNS is provided from Flastat through 3 and 4 in a couple of months. Protocols, standard DNS UDP protocols. It's actually the most recurring, more than 75-76% of our DNS queries. DOH, DNS over HTTPS, DOT, DNS over TLS, and it will come very shortly, DOQ, DNS over QUIC, which is an enhancement of the other two secure protocols, and it's faster, of course. DNS for Flastat provides very important statistics, trend, and valuable indicators for network admins. For example, following our threat report 2025, it analyzes the 2024 past year trend. We can see that pornography, it's in Italian, sorry about that. Our marketing guys didn't translate it at all. Sorry about that again. Pornography, weapons, gambling, drugs, conspiration, discrimination, violence, and online games are the most blocked vector in our customer base. If we talk around the threat, the adware, phishing, botnet, Trojan, crypto mining, malicious scripts, backdoor fraud and scams are very recurring in our customer base. Fine. We mentioned that DNS training is one of the most important concepts you need to know. When I started, I was around 20, 21 years old. As a simple MSP or system integrators, I tried to study very deeply DNS protocol, and I loved it. How the flash start journey did start? We started being for over 10 years managed service provider and network consultant, and then after that we were used to install third-party firewall and security platform. The very famous OpenDNS, now Cisco Umbrella, was one of our top soldest solution. We were used to install OpenDNS widely, but from the beginning, from the very first installations, we found that something perhaps was missing. We wanted to work using a global platform, so a very high scalable technology, but I believe with a bit of Italian inspiration. Italian people love very easy dashboard interface and simplicity, together with a very high level of power and efficiency. The idea was born building an Italian DNS security, and by that the flash start DNS started in Italy, Milan, Bologna, and the capital, and then we starting going abroad in Europe, and after that we started receiving the first leads, the first interests from North and South America, especially South America at the very first beginning, because South American people are very keen to work with European ones. Then the Asia Pacific network started growing significantly, as well as the Australian, the Oceania, with two data centers in Sydney and Melbourne, and by the end of the summer, we will also be online in Wellington, in New Zealand, to cover the other island. The African continent is present, and this is our actual global Anycast worldwide network. With a bit of effort and investment, considering that DNS security and DNS resolution must be faster, and DNS must not lose any single query. DNS must be very fast, typically less than 10 milliseconds, and it needs to offer a very high responsiveness. By that, just after building the global network, we started at the same time we started building our dashboard. The dashboard is the main administration control panel, and it's obviously multi-tenant, so MSPs, system integrators, and telcos will be able to manage the entire customer base through the same dashboard page. This is the home page, showing some nice recaps, such as threat detected, threat blocked, etc. We support 5 different languages: Italian, English, Spanish, Portuguese, and German language, and some other snippets showing, for example, the most blocked application and the most allowed application, such as the global recap in a circle report, and the per hour request DNS trend. After that, some highlights, some insights taken from the report section. Everything is obviously exportable through APIs to an SIEM, of course, and to third-party log management platforms, and the main control panel, the protection one, allows you to tune threat protection, the most important one regarding ICT security, content filtering, for example, to implement parental control on a very sensible network, and application blocker. This is a screenshot taken from the malware section, we can of course block the entire malware, or we can select the a specific category. This is nice because it shows the application blocker. It's possible to block, for example, the entire dating section, e-commerce, file sharing, VPNs. Because if you want to implement a very secure network, it's absolutely mandatory to block, for example, applications such as NordVPN and Firefox VPN, Safari VPN, etc. Because a VPN system doesn't allow you to maintain security, because a third-party VPN system allows a user to circumnavigate filters. That's why it's so important to block VPNs on a security context scenario. The endpoint section is the extension of the network protection. If I go out from my secure network, I believe I will become very vulnerable to attacks. If I surf through the Wi-Fi in an airport, in my hotel, or on a guest network, the network is not secure, and I can be infected as well. And as soon as I come back to my company network, I will be a strong and a very dangerous vehicle of infection. That's why bringing network protection to remote endpoints through application, because we offer dedicated application for Windows, Mac OS, iOS, etc. But we also offer the secure protocol, because DOH, DOT, and DOQ can be easily implemented on endpoint. So we need to bring out the same level of security, same as the internal protected network. Fine. Benchmarking. If you offer DNS security, you need to have a benchmark. The most important one is dnsperf.com. It's a public one, and it performs every minute more than 200 checks from specific location placed all over the world. So in the 5 regions, in the 5 continents, you can have checks and tests from dnsperf.com. This is an highlight showing a tracking log. We are getting query towards our public IP. This is our first DNS. The second is 105.105. It's public. And we are getting queries from Brazil, Lithuania, United States of America, Netherlands, Bangladesh, Ireland, Japan. In other words, global DNS check queries. And starting by January 2025, we had a great surprise. So right now, Flestat is the fastest secure DNS server in the world. If you go to the public dnsperf.com benchmark, you will see in the secure top resolvers that Flestat is the fastest one, and the global DNS resolver with the highest level of efficiency. 99.98% of queries are properly resolved and sent back to the users. DNS performances, of course, and some graphics. This is the public chart. The second is Cloudflare, Google, DNS filters, Cisco Umbrella, Control, etc. But the chart can be different. And since January, we are on top position, and our investments are totally made to keep and to further improve in some regions such as China, Asia, in some pretty hard regions, the latency and the responsiveness of DNS. Now, Just 3 minutes and I will end my presentation. How to increase the stability and the resilience. Flashstart has been built through federations. So, for example, if we work in if we are located in the west coast of the United States, is just an example, we have a federation composed by Seattle, Bend in Oregon, Silicon Valley, which is San Francisco, and LA in California, Los Angeles. The federation works together, and if, for example, Bend or Seattle or Silicon Valley started becoming bottlenecked, or we start having a DDoS attack, which is frequent because every public service based on an IP service can be obviously DDoS attacked, and the federation can distribute query, for example, received on Seattle to the other nearest nodes. When I am referring to a near node, I'm obviously referring to a near node in terms of latency. Okay, so latency is the proximity of the nodes. Obviously, everything is based on BGP, Border Gateway Protocol, and if you're getting an outage, for example, in Hong Kong, DNS BGP traffic will be rerouted to the nearest node, Seoul, Tokyo, Hanoi, Vietnam, Singapore, and Bangalore, for example, in India. Just to end my presentation, let me mention the role of artificial intelligence. It's really critical because more than 10,000 of new domains are properly classified and put online every day. We are able, through our internal algorithms, to predict and properly determine the more than 98.5% of the domain, and we can support as well as more than 45. I believe actually the number is 51 or 52. I need to check. The marketing information is a little bit not updated. Future developments. Together with Antonio, we started having a great discussion around passive DNS. Passive DNS is the ability of going back through the infected resolved IP address, coming back to the domain related to that infected IP address. And since Flashstart protects more than 30 million users with more or less 15, 16 billions of DNS queries per day, using artificial intelligence and passive DNS can bring to a very interesting new malware IP detection. Mixing the great amount of data and the technology that we are gonna implement, and we are gonna put online quickly over next month. So now let me ask to Antonio to come back online, and let's share just 2-3 minutes for any possible question and answer. If you want to use the chat, please be free to place your question, and both me and Antonio will be very glad to answer to them. We can go ahead and share any question. If Antonio want to add something else, I am very happy.
Well, first of all, congrats on your perfect timing. We are perfect in time with our schedule. So I have a question for you, Francesco.
Okay.
This is more a curiosity on the Flashstart system. How much is important to have a low latency on DNS replies?
Yeah, Thanks for the question, and let me share my screen to properly try to give you an answer. It's very engaging, this. Okay, so I'm accessing dnsperf.com. I have premium access, and I can make some queries. So DNS latency is really important, and let me take, for example, the European continent. Okay, now I am performing. Okay, I am performing a simple TXT question in Europe through our DNS server, and I am requesting the TXT record of info.flash.com, giving the landing pop of DNS. So from Europe, Amsterdam, they have multiple autonomous system in the most important and most crowded locations, Amsterdam. We have a reply in it's very small, sorry about in 4 seconds, in Frankfurt 11 seconds, in Dublin 60 milliseconds, Belgrade 28, Stockholm 0 millisecond, Luxembourg 4 milliseconds. Now, having a very low latency, it's important. Number one, to offer to users a very fluid internet experience. Because if I, for example, if I ask to browsing NewYorkTimes.com, sometime I read New York Times, I perform the first query and wait.com, but the website by its own starts calling several third-party websites, such as CDN, content delivery networks, advertising, of course, and a third-party website. If we consider the number of domain involved in just querying NewYorkTimes.com, more or less, there will be more than 12, 15, or 20. The importance of DNS advertising and third-party embedded contents has the side effect of increasing a DNS query. If we are slow, the slowness will be replicated to many DNS queries, and the side effect will be getting the New York Times download very, very, very slow. Second point, the landing pop. It's very important to properly land on the nearest node for two reasons. Speed, of course, if we are querying from Florence in Italy and we land to Milan in 4 milliseconds, it's very acceptable. Google has 7-8 milliseconds. But if we land, for example, from Johannesburg, South Africa to London, because the best way from South Africa is following Liquid Telecom up to London, probably some websites using continental or regional CDNs will not be able to properly sharing contents. We had an issue before putting online some years ago our data center in Mexico. The Mexican users were used to land in Dallas or Atlanta. Dallas and Atlanta are, or Los Angeles for the western part of Mexico, are the nearest node. The latency was between 15 and 20, 25 milliseconds, so I believe fairly acceptable. But some CDNs at that specific time, such as Netflix, were refusing sharing contents for Mexico. And that's why some global content delivery network and some global websites weren't accessible using Flashstart. And we quickly understood, I was talking about 7-8 years ago, quickly understood the importance of local nodes to properly share CDNs. If you are working in Europe, for example, AWS, Prime Video, Netflix, etc., can serve content from Italy to Spain to United Kingdom, doesn't matter. But if you are talking about South America and North America, or from Asia to the Middle East or to Europe, there might be some very borders in terms of availability of CDNs that will prohibit a specific user to browse content. That's why we monitor point number one, latency, and point number two, the landing POP. Landing on a proper POP is strictly important, and that's why Flestart, I believe, made important investments to guarantee that every single query and every single website was properly resolved and properly landed to the best nodes for every context, Antonio.
So, Francesco, can we say start cutting DNS latency in order to have a smooth surfing experience on the net?
Yes, definitely we can.
This is for the right query to have the right reply in very quick. But if I query for a malware website, for a bad website, is the reply with low latency as well?
Yes, obviously, if you set up to block malware contents, you will show the stop page with your logo and with a stop signal. And the stop page are clusterized by region. We have a stop page cluster in Europe, one in Asia, one in Africa, and one in North America. Honestly, the cluster is global by region, so the reply, the stop page, the logo might come in 20, 30, 40 milliseconds, but the DNS reply is immediate. I believe sometimes it's better to show the stop page with a bit of delay, because if you're under a DDoS attack and your computer, for example, has been compromised and you are getting a lot of DNS hits against an infected website, if we reply with the stop page in 0 millisecond, probably that computer will have much more difficult than ever. And that's why a bit of latency downloading the stop page can help you to, I can't say mitigate, because you should disconnect from the network that dirty machine and then installing from scratch the operating system. But at the moment, the impact on internet traffic could be lower.
Wonderful. So, is there any questions from our audience?
I have a question for you.
Oh, for me? Yes, please.
Yeah, I'll go for it. So I mentioned previously that Flashstart supports traditional DNS and the new DNS, DOH, DOT, and DOQ. Do you believe there might be in the future an override of the new DNS secure protocol against the old UDP protocol, considering that when we work with tier one carrier, we work with a purple carrier in the United States of America. I can say the name because we are under NDA, but it's one within the top three telcos in the United States. They absolutely don't want to use DOH, DOT, because they say DNS, standard DNS over UDP, vintage DNS is better. Do you believe new technologies might overcome the vintage UDP DNS resolution?
I think it will happen. It will happen soon because it is a matter of privacy and security above all. I mean, when you have your queries protected under TLS, for example, I think it could be an value added service for the end user. So maybe what is based on HTTP could be less efficient. I agree on that. So between HTTPS and traditional DNS, I would prefer the traditional one. But when we talk about DNS over quick, I would say that it will end as the HTTPS now is working. I mean, the main web traffic is on quick, and quick is a method to replace to put TCP inside UDP. So I think that DNS over quick could be the game changer in DNS. It requires time, of course, but I'm sure it will happen.
Great. Thank you for the answer. So thank you for everything. Thank you for the patient, and I hope our content has been interesting. The webinar recording will come over, I believe, tomorrow or later on Monday, and together with some information. And let me share the Flashstat website, https://flashstat.com. It's obviously possible to try for free for 15 days Flashstat, and it's possible, of course, to request to book a demo and get prices. And if you want, Antonio, if you want to share your website, please be free to do it over the chat.
Okay, this is my website where you can find all my presentations that I gave over time. But anyway, the presentation I gave today will be available, Francesco, as well as yours, I guess. So I gave you to your marketing team. It is under Creative Commons license, so everybody is free to redistribute and use as you want.
Thanks a lot. Thanks, Antonio. Very honored to add your presence this morning or this afternoon or this evening for our friend from other parts of the world. The registration will come, and thank you all. Keep in touch, because there will come great news regarding the total dashboard engineering of Flashstat by the end of the year. And I believe at the end of August, we will share the global announce and a specific webinar over that. Thank you so much. Great cheers from Italy. Bye.
Bye.